And then here I could even verify that I have published my event properly. So let's say that the title of the event should be, let's say, the request title. Hey guys, it's Peter from DevMentors and welcome to the 11th episode of Building FeedR Microservices.NET 6.0 based series. In this episode, we'll talk about our web API testing. So, during this episode, I want to talk about web API testing, especially testing our endpoints. So, for example, you could be able to, let's say, test your get, post, put, pretty much any kind of HTTP endpoints as you can think of by running your web API fully in memory. So let's say then that's one test case scenario that we would like to focus on. And the other one, which is also going to be related to our web API testing, however, it doesn't have to be. It could be also, let's say, plain integration tests without starting the whole app in memory. But in this second scenario, in this second test case scenario, I would like to show you a way to additionally, of course, if you have a need to do this kind of testing, to additionally show the way how to be able to test some kind of asynchronous stuff. So for example, you can imagine something like, I don't only want to test if my, let's say, post to /orders returns still one created. Maybe I would also like to be certain that, for example, when this response code is returned to me, that somewhere behind the scenes within, let's say, the background part of my order service, there is this specific, let's say, order created event being published, and it's being published correctly to the real message broker. And then on the other side of my message broker, being the consumer, I could somehow asynchronously await and receive this, let's say, event within my kind of integration end-to-end, but pretty much looking like written in code unit test, so that I could be not only certain that my API has successfully fulfilled the request, but I'll be also certain that my API has sent this specific message, and that on the consumer side, I was able to actually subscribe to this message, receive it, and maybe even process it. That, for example, this message contained all the properties as it should have contained. So this will be a bit of, let's say, pushing this stuff to the extreme, but I think you'll see a very simple technique that you might find useful when you have a need to write this kind of extended asynchronous test. All right, let's imagine we would like to do this kind of integration or end-to-end testing for our web API. So let's say we want to test the currently rather empty newsfeed, but we'll see what we can do about it. So I'm going to create a new project, and let's just add this project into our FeedR directory. So here, let me just jump into our newsfeed like there. And I'm just going to add this feeder.fits.test.end-to-end or integration testing for our newsfeed. Okay, so let's make a new project like this, and I will use the XUnit as a framework, and let's just create this one. And let me start by at first removing this test dummy class, and by adding two libraries. So for the NuGet, I'm going to install the integration testing package coming from the Microsoft. So there's this MVC integration testing, MVC testing, yeah, this one. And I also want to install one more package, which is called shouldly. You can also find the Fluent assertions. The idea is pretty much the same, just to be able to write your tests, write your assertions using this Fluent API. So I will start by adding the new component. So I will call this one news test app. Okay, and this news test app will derived from the web application factory, so the component coming from this ASP.NET Core MVC testing package, the official package built by the Microsoft team, and this will actually inherit our program. So not really inherit, but this will make use of the program CS. So we would like to somehow use this program, but this by default is internal. So it's not visible to our news test app. So we could either extend this one with the attribute, the assembly attribute with internals visible too, or we can jump into the definition of our CS approach here, and we can simply provide this new item group. So item group, and then within the item group, I'm going to add this internals visible to and my project. So includes and the project name. So I want to allow this test project to be able to view the internals of this FeedR feeds news project. So now I should be able to, as you can see, import this missing reference. So let me just rebuild this just to be certain it will work as expected. And if I haven't made any mistake there, internals visible to, this should allow me to see this within this project. So let's jump here once again. And yeah, as you can see, I can reference this project now and import the program type. So good, we are now good to go. And I don't really need to do anything else within my news test app, at least for now. So now let's try to write some tests. So I will make this simple. I will just add a new class, and I'll call this one, let's say API test. So let's make this public. And I also mark this one with the exclude from code coverage, because I don't want this test class to be part of code coverage, because it doesn't make much sense. And I can also provide this attribute here, because I don't want this to be under my code coverage. And what I will do now is write a very simple test for our API. So let's make a test. Let's call this one something like get base endpoint should return OK status code and service name. So I want my test to be very descriptive, what it does, how it does the things it does. So I'll mark this one with a fact attribute coming from the X unit to make it a test. And now I'll just extend my program CS with a single method, with a single endpoint that I would like to somehow test. So somewhere here, as you can see, we actually have this endpoint, so we can just reuse this one. We'll just add more endpoints later on for additional testing. So let me put a breakpoint there, right here, okay? And let's try to write the test for this endpoint. So what I will do within our API test, I will simply at first construct our app, okay? So I will start with doing the following thing, which is going to be app equals new news test app, like this. And then I can do client equals app create client. So I can ask my news test app, which derives from this web application factory, to give me the HTTP client back. However, I could also ask my app to pretty much override anything. As you can see, we can use this with web host builder, and then within our builder, we could override easily, for example, our IOC container, our middleware configuration, and all that stuff. So you can imagine, for example, writing your integration or end-to-end test for your microservice, or pretty much any web API or web app in general, which might talk to database or which might talk to some external service. And then maybe you like to mock database, more external service, mock some file IO or some network calls. You can override all the stuff through the IOC container. You can override the middleware, so it's very, very nice feature. So let's finish our test. So I'll make a request. So I'll expect some response from our client. So I can do clients and then simply get async, and I'll provide here the base endpoint. And finally, I can do, let's say, response. I can do some assertions there. So response, and of course, I'll await this one. Response, and then status code should be status code OK. So HTTP status code OK. And finally, I can read the content. So the content will be simply await response content read as string async, and I will expect this content to be of FeedR newsfeed value. So content should be, as you can see, I'm using this surely library here to make these assertions the more fluent way, so I don't have to write this assert dot equal etc. So this is our very first test. All right, now let's see if this is going to work. So I have a few breakpoints within our endpoint and within our unit test, actually, or integration test. And let me run debug, and let's see if this is going to work. And if it works, we are going to move to a more interesting sample. So yeah, let's take a look. There is a request. We are hitting our API running fully in memory for this HTTP server test server abstraction. There's our response. Okay, there's our content, and our test is green. Our test has passed. Great. Now, let's think of more interesting tests. Okay, so imagine the following scenario. Let's say that somewhere in our newsfeed, we could have some kind of messages. I will just put them under messages just to illustrate what I have in mind. And I will have one message called this, let's call this publish news. Okay, this could be actually of record type. So let's say this could be some kind of message or request or comment, whatever you call this. Let's imagine that I want to be able to publish some news, and I have to provide the title of the news, the category, maybe some kind of the content description, etc. Okay, so this is some kind of the request to publish the news. And then I will make another kind of message, and I will call this one news published. Okay, so I want to notify maybe other microservices, asynchronous with the message broker, or maybe through Redis. I want to notify them in some way that maybe someone just published a news, because this is what my feed is all about. Just like I can stream the quotes, the pricings, the currency pairs, my weather data, like we did in these two microservices separately. I want to also be able to maybe stream some news, okay, that I can publish or some other users may publish through our system. So I will have this news publish kind of message, kind of event that I want to asynchronously send from between my microservices, originating within our FeedR feeds news microservice. And now let's say that I'm going to add one more endpoint here. So I will make a simple map post endpoint like this under news, and here I will expect that the user of the API will make a request with this publish news, with this object, with this, let's say, JSON request. And I also want to put there, I also want to make use of our stream publisher here. So stream publisher, like this. Okay. And then I want to somehow, let's say, publish this news through our stream. So imagine that I have some kind of business logic. I'll just mark it here to do handle and news. Okay. Save to database, etc. And finally, I'm just going to produce some kind of event. So there will be my integration event. So new news published, and I will just provide my news category and news title. So the other way around, news title and news category. And then I'm going to call my stream publisher and then publish async. And let's say into the topic called news, I'm just going to publish this event. And finally, since this is the asynchronous result, asynchronous kind of task, I could just return the result accepted as my status code. So 202 accepted. I have accepted your request and I did something with your request, and maybe I sent some asynchronous event within the scope of your request. Okay. Just to make sure that we will not fail, at first, let's just add the required components. So before we build our app, let's just extend our builder services with the following. So I want to add the streaming capability. I want to add our Redis. So by providing the Redis configuration, and I want to add the Redis streaming. So I want to have this Redis streaming stream publisher. So we are actually publishing the data to the Redis, and through this Redis pops up mechanism, not somewhere in memory, which would be dummy. And I can, of course, extend this with the correlation that we talked about in the previous episode. So I can do some correlation, I can add HTTP context accessor, and I can also add, for example, the serialization. So let's say this is the minimum amount of extension methods I want to call to be able to stream some data further. And of course, I need to extend my app settings with the Redis settings. So here I can just, for example, take my Redis settings from the existing, let's say, settings within the code services. I'm going to reuse the same connection string. So let's just add this one here. All right. So what I can do now is the following. I could try to write another test. So let's jump back into our API test and let's try to implement additional integration end-to-end test. So let's make another method here, test method, and let's mark this one with the fact attribute. And I can call it something like post news should return accepted status code and publish news published event. Okay. So once again, rather clear and descriptive name, what this particular method, what this endpoint should do. What do we expect from this endpoint? And of course, this is going to be of task type. So once again, what we'll do is we can create our app and a client, and actually we can refactor this. So let's make a constructor that will be called every time the new test starts. So I will simply do something like app equals new news test app. All right. And let me just put it there. And probably this is the very first and last time when I use region in my life. So I can call this region arrange. So I will put there the test app, and I can also put there our HTTP clients. So this will be created every time whenever we invoke the new test, and then the client will be our app create client. So we can get rid of this here. We can just call our client generated by the constructor every time that the new test starts anyway. And let's at first see if this is still going to run, if we didn't break anything during this refactoring. So it's still up and running. So now that we know that everything's up and running, let's try to invoke our post method. Okay, let's try to somehow test this one. So what I can do is the following. I will make a request. So new publish news, just as we expect here, this publish news object, very simple data, title, and category. So let's provide here something like test news, test category. Okay. And let's call our API, our HTTP client. So await client, post as JSON async. I'll use this extension. I want to hit this news. I don't need to use the slash. I can use it, but I don't need to use this. And there is our request. And at first, I want to be certain that our content, that our status code should be and then accepted. Okay, so let's give this one a try. Let's see if this is going to work. I'm going to run this in debug mode once again, and let's just put some breakpoints here. And let's see. So we are hitting our request, our endpoint. There's our data properly serialized using the JSON serializer. There is our stream being sent to the Redis, result accepted, all good. So in this case, you could assume that, all right, it's all fine. We send this request, we have received the response, this accepted status code, and that's all good. However, you might also think in some scenarios about some additional assertions. What if you would like to write some kind of a test that actually really gives you this kind of credibility, which verifies that you actually publish this through the stream, and that, let's say, there was nothing wrong with this message, that the message has been properly sent through the stream, and that you can even somehow subscribe to this news stream, or whether this is going to be Redis stream or message broker, Pulsar, Kafka, Rabbit, Azure Service Bus, whatever it is, that you could somehow, for example, subscribe on the other side to act as a consumer of this message and somehow test that this specific endpoint published this event, and that this event could be received by you somehow within those tests and be validated additionally. So you'd have kind of like full-blown sort of end-to-end test where you are not only making a request to your API and validating, asserting that you have received a proper status code as a response, but you are also verifying maybe this request published some event or saved something to database additionally. Okay, so this would be like some more in-depth, extended kind of test. So the question is, can you do it, or can you do it easily? And the answer is yes. So let's try to do the following. Let's say that I would like to somehow use our stream subscriber to subscribe to this specific topic. So I would like to subscribe to this news topic and listen to this event. All right. So what I can do, instead of actually trying to create this on my own, so I could of course try to do something like create new Redis stream subscriber. So we have this subscriber here, and I could make this public, or I could change this visibility of this one by using this assembly attribute and internals visible to, right, as the attribute. So I could change the visibility of this internal type, but I would like to somehow get this already configured Redis stream subscriber or Redis stream publisher from my already running HTTP server in memory, right, with using this app settings that has been loaded into the server and so on. So since we have an access to our app, what I can do is something like app, and then as you can see, we have our service provider. And we have also our server. So I could simply ask for the services. I could just try to either create a scope for the service provider, but since we have registered our stream subscriber, as you can see, we have registered this one as a singleton. I don't need to create a separate scope for this. I can just ask for get required service, and then I want to I want to get a single instance, the singleton instance of our iStream subscriber, which in this case should be our Redis subscriber. So let's move along, and somewhere here I will call our subscriber, and I will call this subscriber.subscribeAsync, and then news published. So I want to subscribe to this specific event, which should be published by our API to this specific news topic. And I can do pretty much anything here. Let's say something like message, and then do something with this message. So somewhere here, I'd like to say, okay, my test has passed. So we'll see how we can actually achieve this. All right, so we can subscribe to our news publish here. Let's just put a breakpoint here, and let's see if we can actually somehow receive this message. So I will run this in debug mode, and let's see what is going to happen now. So let's try F5. And as you can see, we have actually received this message, right? So that was kind of quick. We have received this message. So if we take a look once again into our program CS, let me just put a breakpoint here once again. It was very quick, right? So we are kind of lucky. So let's just run this once again. We're kind of lucky because it's been very fast. So let's make a request once again. We are hitting our endpoint, we are publishing this event, and before we even hit the next breakpoint, as you can see, we have already managed to receive this message there, and then there is our message. But imagine if this was actually kind of long-running operation. Let's say we wouldn't be so lucky. Let's say that this message would be published after some time. So for example, let's say that somewhere here we would have some kind of ongoing background process, and then maybe after, let's say, 5 seconds, this would be published. So for example, we would have some kind of a delay, and after this delay, this would be published. So let's say I would start a new task just to kind of show you what do I have in mind. So let's say I have 5 seconds, and after 5 seconds, I would let's say, publish this event. So let's do something like this, which of course isn't the appropriate asynchronous code, but this should do the trick for us. So this is our previous task, and let's say here we are publishing this event. So let's see if we can actually somehow get the same result now. So we are now kind of simulating some kind of asynchronous process which takes place and which eventually results in this news publish event being sent through our Redis PubSub. So let's run this test once again, and let's see if we will still be so lucky or not really. So there is our gate, there is our endpoint. We're making the request. We are constructing our events. We are returning accepted from the gateway. And unfortunately, well, the test has passed because we didn't wait for this, but we didn't really get to this point, right? But we want to be certain that we actually send this message. But as you can see, we weren't so lucky this time because it took maybe a few seconds, 1 second, 5 seconds. We don't know how many seconds it took, but we still want to be certain that we can verify that this message has been published, not only published, but published correctly. And if we were the consumer of this event, we would like to be certain that this is the appropriate event, maybe with appropriate data, sent properly through this Redis PubSub. So we want to have this kind of full-blown end-to-end test. So can we fix this? Well, yes. And we can fix this quite easily with the usage of TaskCompletionSource. So let's take a look at the following. I'm going to make a new TaskCompletionSource, and the result, the generic type of this TaskCompletionSource, will be our news publish. So what I will do is the following. Within our subscribe async, I will simply call TaskCompletionSource and then set result. So I will say that this is some kind of task completion sort for this specific type, news published, and in order to await for this task, which will end here, in our case, after 5 seconds, after publishing this message for our API, I'm going to call this set result, which will allow me to successfully await this underlying task completion sort task, and it will allow me to wait until this event gets actually published through our API. So it doesn't matter whether this is going to be 1 millisecond and we could be lucky once again, or whether this is going to be half a second or 2 seconds. I'll be certain now that I will wait until our API publishes this event. So what I can do is something as simple as await, and then I can await our task. And as you can see, this task would give us back our event. So event equals await our task completion source task. And then here I could even verify that I have published my event properly. So let's say that the title of the event should be, let's say, the request title, and maybe the category of the event should be the event category. Now, keep in mind that, of course, this kind of testing would be probably handled in different places, maybe by your unit test that would assert that your, let's say, event mapping works correctly. But just to show you that you can do pretty much anything that you want within your test, including some crazy stuff like this. So yeah, let's give this one a try. Let's see if this is going to do the trick. So I am going to make this request once again here. So let's see. There is our request. There is our result accepted. And now we are awaiting. So yeah, as you can see, in about 5 seconds, we are hitting back our gateway. We're actually back to our breakpoint here within our microservice, which now publishes the event, and we are setting the result of our task completion source, and we move forward with the test. So if I run this test once again without debugger, you will see that this is going to last about 5 seconds because we made this delay here for 5 seconds. If I make this, let's say 1 second only or 10 seconds, it will last 1 second, 10 seconds, or how long it needs. And this is going to be overall execution time of this test. So this is actually the very simple way of performing some additional, more complex tests, of course, when you need them, when you have to deal with this, especially with the asynchronous messaging. So you can run those tests by using this MVC testing package, where you start your whole API in memory, or you could even just extract this specific logic, what I would suggest to do anyway, into, let's say, dedicated component, dedicated application service, dedicated command handler, whatever you call this, and you could just test your command handler, your application server separately outside of the scope of your API, so that you wouldn't have to actually construct and start your API and make this HTTP request to your API to test this event functionality. But the core idea is that if you are dealing with some asynchronous processes and you want a way to somehow test them, the task completion source, setting the task completion source result in this asynchronous callback, in this asynchronous handler, is pretty much the way to go. So yeah, that's all for this episode, and hopefully you have seen how easy it is to build, to implement your integration / end-to-end test for the web API with the usage of this great library provided by the Microsoft teams for testing your whole web app, web API in memory, and how easy it is, for example, if you'd like to override your IOC container middleware, you can do pretty much anything with it. And then, but like I said, you don't have to use this library. You could even write a plain integration test in memory. You could just, test your application service or command handler or whatever by providing all the components. And then, let's say, within those components, when you publish some kind of message, even to the message broker, you can not only be certain that this specific message has been actually received by your broker, but you can also subscribe to the other side, to this consumer side of this message. And by using constructs like TaskCompletionSource, you can make your test wait in a proper asynchronous way to actually see if this message has been properly received, if the subscription is working, and so on and so on. So just keep in mind that you might find this kind of tests maybe not suited for your cases, and just keep in mind that these tests might take longer to complete, so maybe it doesn't make sense to run them all the time during your CI/CD pipeline because it requires your whole infrastructure to be up and running, but this can give you this additional certainty that everything works correctly, not only your code, but also all this important infrastructure that you are using when building microservices. So that's all for this episode. Thanks for watching. Subscribe if you haven't already. Check us out on Instagram and other accounts. And I will see you in the next final episode.